Vinson will speak, he'll give his presentation, and then after that, we'll have about 10 to 15 minutes for questions to happen. Butler and I will ask questions first, and then I'll open it up to anybody else that's on the Zoom link or in the room that would like to ask questions. They can do it at that point. After that, we're going to take 15 minutes. Everybody will kind of leave the room. I'll shut down the Zoom call, and then me and Butler will collaborate on that.
Okay. Sounds good.
All right, kick it off, man.
All right. Hello, everyone. My name is Vinson, and I'm going to talk about a multidisciplinary approach to extract learning standard-based educational content from commercial video games. Now, before I do that, I'm going to first talk about the rise of digital game-based learning. So a challenge that educators are facing in today's classrooms is creating an engaging learning environment for their next generation students. A proposed strategy is to employ stealth learning by using non-traditional teaching tools such as video games to promote fun in learning. And there is a increased interest in the integration of video games into the classrooms because video games are widely popular. In just 2018, the global commercial video games market generated $139 billion in revenue. That means that it has made more money than industries such as film, music, and sports combined. There are 2.8 billion players worldwide spending on average over 6 hours per week playing video games. This immense popularity is a key contributor to the rise of digital game-based learning. Now, in implementing digital game-based learning, educators often partner with game developers to build new games with the primary purpose of education. So for example, math blasters. However, people call these kind of games the chocolate-covered broccoli because games like these overlay the content that they want to teach with gameplay as an extrinsic motivator to encourage engagement to the learning content without appropriately relating the learning content to the gameplay. So back to the example of math blasters, the questions that you see on screen, they don't have to be about math. It can be English, science, history. There is no deep connection between explosions in space and arithmetic and math. And furthermore, there is a study that has shown that without appropriately relating the learning content to the gameplay, then there is a dissonance that can occur when students switch between the disconnected context of learning and gameplay. And that breaks that long-term state of full immersion and focus known as the flow. Now, there is an alternative to building new educational games, and that is to use the commercial video games that we have right now that we know are successful. So for example, Mario. And we're using these existing commercial video games because this research argues that games like these are inherently learning tools. A world-renowned game designer and developer, Nicole Lazzaro, her 4 Keys to Fun model says that a key contributor to fun and engagement in commercial video games is to create an environment that will present obstacles. And these obstacles will challenge and motivate the players to adopt new skills, which they will apply to advance and achieve their goals. This aligns with constructionism and situated cognition, which are 2 well-established principles of learning. The combined theories say that by inserting students into authentic situations that require certain knowledge and skills to succeed, and then we give them the room to safely experiment and interact with their surroundings, then the students will acquire those set knowledge and skills to succeed. So this suggests that video games are inherently safe environments that can facilitate learning. And beyond that, video games employ numerous design techniques to further enhance engagement, such as the use of compelling graphics, deep lore, and skill balance throughout the game to induce flow. So based on all of this, this research hypothesizes that utilizing the inherent learning facilitating capabilities and deep engagement techniques of existing commercial video games can help us enable student learning while enhancing their learning engagement. So to this end, this research proposes the DeCAD Framework. It is a systematic methodology to extract learning standard-based educational content from existing commercial video games without modifying the game. And this research uses learning standards to extract educational content from existing commercial video games because learning standards concisely outline what the students are expected to know and be able to do at specific stages of their education. This framework was used by a grant-funded project on teaching computer science and computational thinking with gaming. And as a vertical slice of the project, we selected 2DA08 to be our standard. This is a K-12 computer science standard on data and analysis that we reference from the Computer Science Teachers Association. Now, for our game, to facilitate 2DA08, we selected Mineplex's Lumberjack Tycoon. And this is a Minecraft mod where players receive craft orders to complete They earn currency by doing so, and then they can take this currency to upgrade their tools and their buildings and take on more complex crafting orders. To effectively execute this process, we formed a multidisciplinary team of learning scientists and game developers to help us facilitate learning in a Minecraft environment. We needed learning scientists to help us build instructionally appropriate learning opportunities, just as we need the game developers to help us create compelling game experiences to create and sustain engagement. So here is a high-level picture of what we want to achieve. To teach data and analysis in computer science in the Minecraft world, we first inject the students into the Minecraft world and task them with chopping trees to collect wood blocks. Now, if we view these wood blocks as data, then this process of harvesting trees could emulate data collection. And when the students collect these wood blocks and compile them into their inventory, then they can be introduced to the concept of data organization. Now, if we combine these two processes with students exploring the Minecraft world, visiting different biomes, and spend some time to harvest wood blocks from each, then students will start to form an understanding of wood distribution across biomes. So later on, when the students are being presented with a high-level question as a test, such as which biome in Minecraft is most profitable to build a lumber mill in, then the students will be able to draw from their data collection and data organization processes that were facilitated by Minecraft's harvesting and inventory systems. We want to emphasize that we are not modifying the game to incorporate educational content. Rather, we're using the original game elements and we are driving the native gameplay with education-oriented questions, objectives, or narrative. So here's the process in more detail. The DeCAD Framework consists of 3 phases. The first phase is the decomposition phase to guide us through the breakdown of a learning standard and an existing commercial video game into components. A connection phase to identify overlaps between the learning standard and the video game components. And then an activity design phase to utilize these overlaps to design game-based learning activities. This framework takes inspiration from the backwards design framework by Wiggins and McTighe, where instructors first identify the learning outcomes that they want to achieve by the end of lessons. Then they design assessments to measure said learning outcomes. And then they design the lessons based on the assessments. So the team first began by entering the decomposition phase to identify our desired learning outcomes and what in a game we can use to facilitate those learning outcomes. So the learning scientists from our team took our selected learning standard and first broke it down into steps. And these are high-level order of processes relating to the learning standard. And then for each of these steps, we broke it down into the objectives and importance to learning the steps, the evidence of mastery, which refers to behaviors that students display to demonstrate that they have mastered the step by acquiring the necessary knowledge, skills, and abilities. We also identified evidence of learning, which are behaviors that students display to demonstrate that they are learning or progressing towards mastery of that step by acquiring the necessary prerequisite knowledge, skills, and abilities. So here's an example. For our selected computer science standard 2DA08, which is to collect data using computational tools and transform the data to make it more useful and reliable, we first broke it down into collect, clean, organize, and explain data steps. And then each of these steps are broken down into the components shown on the subtable here. And the team built a standard decomposition table to compile these components from each of these steps. Now, in the same phase, a game developer from the team took the commercial video game selected by the team and performed a similar decomposition process on it. We identified the gameplay loops, namely the core, secondary, and tertiary loops. And then we identified the mechanics, which are systems that functionally enable the gameplay. And then the game stats, which are data or metrics associated with the mechanics. The team has defined these components as functional components that are directly involved in the later decode phases. And these components must remain unaltered so we can preserve the inherent engagement value of the game, and we can avoid compromising the game's integrity and disrupt their flow. Now, we also identified design components such as the pillars, themes, and aesthetics. And these would serve as design guides in the later decode phases to help us prevent introducing elements that are inconsistent with the game as we design game-based learning activities. So for our selected game, Mindplex's Lumberjack Tycoon, we build a game decomposition document compiling information on all of these components. And since Lumberjack Tycoon is a Minecraft mod, the official Minecraft wiki, which is a community-driven encyclopedia, was a key resource to this decomposition process. So now that we have identified these learning standard and video game components, then we enter the connection phase, where the team discuss how Lumberjack Tycoon's game components, such as the gameplay of harvesting trees, could help facilitate learning opportunities related to 2DA08's learning standard components. We want to understand what the learning standard looks like in the context of the game. So we first define learning behaviors exhibited in the learning standard components, and then we identify gameplay that can emulate or facilitate said learning behaviors. So for example, a learning behavior that the team has identified related to 2DA08 is to collect at least 2 types of data exhibit in the evidence of learning for the collect data step. A gameplay that could emulate this is players chopping down trees to collect wood blocks and leaves. We call the pairing of the learning behavior and the gameplay the learning facilitating gameplay activity. The gameplays from these LFGAs are extracted from the gameplay loops that we have identified in the decomposition phase, and then the team devised a strategy to map learning behaviors from different learning standard components to different gameplay loops. And this helped us establish multiple layers of connections between the learning standard and the game based on the time scale and the task complexities of the learning behaviors and the gameplay. So here is our strategy. We mapped learning behaviors from pre-KSAs and some of the KSAs to the core gameplay loop because students engage with the pre-KSAs and KSAs regularly throughout the interaction with the learning standard, just as in video games, players engage in the core gameplay loop regularly throughout the game. We use learning behaviors, we mapped learning behaviors from the evidence of learning, KSAs, and some of the pre-KSAs to the secondary loop because they contextualize the need to first engage with the pre-KSAs and KSAs beforehand. Just as in video games, the secondary loop contextualizes the core gameplay loop. And then we map learning behaviors from the EOMs and some of the EOLs to the tertiary loop because learning and mastery contextualizes interacting with the learning standard on a long-term scale. And also they contextualize the need to engage with the previous components beforehand. Just as in video games, the tertiary gameplay loop contextualizes the core and secondary loop. So now that we have defined the mappings between the learning behaviors and the gameplay and defined our LFGAs, then for each LFGA, we identify the mechanics that could functionally enable the gameplay, and then the game stats associated with the mechanic. This informs us how the learning behaviors could be quantified by the game. It is through the game stats associated with the gameplay that reflects that learning behaviors. So back to the example of players chopping trees to reflect the learning behavior of collecting at least 2 types of data. A mechanic to enable this gameplay is the harvesting mechanic that allows the players to destroy trees to collect the loot. A game stat that could be used to quantify this learning behavior will be to access the namespace IDs to tell us what the players have collected. And this will tell us if the players are indeed collecting at least 2 types of data to reflect the learning behavior. Here is another example of a learning behavior that is facilitated by the game. A learning behavior could be to depict data in useful and reliable ways, exhibited in the knowledge, skills, and abilities for organized data. This can be facilitated by students organizing their collected items in their inventory. This is facilitated by the inventory mechanic, and we can access the stack number to see if the students are utilizing the inventory to depict what they have collected, and we can also compare that with the students' explanations to see if they are interpreting that depiction correctly. Now, in order to provide access to the previously mentioned game stats for instructors to assess their students' game-based learning, the team built a backend communication pipeline using AWS to bridge between Minecraft and Canvas. This would allow instructors to access and visualize their students' Lumberjack Tycoon game stats and assess their game-based learning on Canvas without ever needing to enter Minecraft. However, as the team worked to define more LFGAs, we realized that Lumberjack Tycoon could not naturally facilitate all of the learning behaviors related to 2DA08. So for example, there is no gameplay that can naturally emulate or facilitate the learning behavior of creating graphs to visualize data, exhibited in the evidence of learning for organized data step. And while you could argue that players could technically build constructs that resemble charts, this is not a gameplay that is consistent with Lumberjack Tycoon's theme of crafting to fulfill orders and continuously improving on efficiency to take on more complex crafting orders. So this informed the team that there is a deficiency in Lumberjack Tycoon's ability to naturally facilitate the learning behavior of creating graphs in a way that is thematically consistent with Lumberjack Tycoon. So this led us to another part of the connection phase, and that is to supplement these gaps. Again, we are not modifying the game to incorporate educational content to address these gaps. Rather, we take these unmapped learning behaviors and these learning standard components to inform the development of a companion tool that we can use to supplement the game, address these gaps, and thereby more fully addressing the learning standard. So the team defined tool functionalities to supplement these gaps, and thereby defining new LFGAs. And then we define the tool features to enable these functionalities, and then the tool data to help quantify the learning behaviors in these new LFGAs. As we're designing the companion tool, we reference Lumberjack Tycoon's pillars, themes, and aesthetics to make sure that we are designing interaction loops that are thematically consistent and compatible with the game. And this led us to build Minecraft Factory Planner. This is a graphical planning application where students can build the node maps to communicate the resources that they need to collect in a time frame to reach the production rate of a certain item. The team also built in a graphing feature that allows students to build pie charts, bar charts, and line charts to communicate information such as resource collection rates, resource consumption rates for production, and production output rates. The AWS backend communication pipeline extends to the companion tool as well. So this means that Lumberjack Tycoon's game stats, as well as Minecraft Factory Planner's tool data, are shared between Canvas, the game, and the companion tool. So with the development of Minecraft Factory Planner, we're able to address the previously mentioned gap in creating graphs. Now, students can build bar charts, line charts, and pie charts to help visualize data. This is facilitated by the graphing feature, and tool data that can be used to quantify the learning behavior will be to access the graph type and see if students are using the correct graph to most effectively visualize data and communicate information. Another example of learning behavior facilitated by the companion tool is to discover relationships exhibited in the knowledge, skills, and abilities of the explained data step. This can be facilitated by students building node maps to communicate the resources that they need for production. This is enabled by the node map feature, and we can access the input rates and output rates of the node maps that the students have created and compare that with the students' explanations to see if they are correctly interpreting the relationships between the nodes in the maps that they have created. Now, an example of more complex behavior to demonstrate mastery is to structure arguments to make claims, exhibited in the evidence of mastery of explained data. So for example, a student may claim that in the Minecraft world, the forest or jungle biomes yield the most wood and therefore is most profitable to build a lumber mill in. This can be facilitated by students using Minecraft Factory Planner to access their Lumberjack Tycoon's inventory data after spending a certain amount of time harvesting wood from each biome. This can be facilitated by a number of features, including the data access, node map, and graphing features of the companion tool. And then we can access the inventory data and the output rates of the students' node maps and compare that with their explanations to see if their claims are accurate. So now that we have discussed how 2DA08 could be facilitated by Lumberjack Tycoon and Minecraft Factory Planner and define these LFGAs, then we take these LFGAs and enter the activity design phase. And this is the last phase of the framework to help us design a game-based learning activity plan. So the team defined fundamental tenets of information to communicate the details on the game-based learning activities as well as the learning objectives, but we leave room for instructors to incorporate these activities into their curriculum in ways that best suit their needs. So here's the outline that we have defined. We defined the learning objectives of the activity plan, the game-based learning activities that the students will engage in, the materials to facilitate the activities, and then the assessment opportunities for instructors to assess their students' game-based learning. Now, to expound on this outline, we use the LFGAs that we have defined in the connection phase. So, for example, we use the objectives and importance related to the learning standard components of LFGAs to explain the learning objectives of the activity plan. We use the gameplays in the LFGAs to explain the activities, the mechanics that functionally enable the LFGA gameplay to explain the materials. And then for assessment opportunities, we provide access to the game stats, as well as explanations on how to interpret the game stats in relation to the learning behaviors in the LFGAs. And we applied a similar mapping strategy for LFGAs associated with the companion tool. So we mapped the tool functionalities of the LFGAs to the activities, the tool features to the materials, and then the tool data to the assessment opportunities. So here's some example high-level activities designed by the team. We set our first activity to be a Lumberjack Tycoon tutorial to onboard students with the core gameplay such as movement, harvesting, and inventory. A learning objective will be to identify and collect relevant data. An activity will be to collect the resources that are needed to build a bookshelf. This is facilitated by the harvesting mechanic of Lumberjack Tycoon. And for assessments, we can access the namespace IDs of the students collecting materials to see if the students have indeed collected the relevant materials to build a bookshelf to fulfill the learning objective. A tutorial following that will be one for the Minecraft Factory Planner to onboard students with the core features of the companion tool, such as node map and graph creation. And we can also task students with creating a craft plan using the node map based on a craft order that they have received in Lumberjack Tycoon. So for example, build 10 bookshelves in an hour. This a learning objective for this activity will be to organize the objects through comparison. An activity will be to create node maps to plan for the bookshelf production. The material to facilitate this activity will be the node-based mapping feature of the companion tool. And for assessments, students can compare node maps with each other to evaluate on their own strategies and also to improve on their efficiency. Now, after the tutorial activities, the students can take their craft plans that they have built in the companion tool and enter Lumberjack Tycoon to validate that craft plan and fulfill the crafting order. So a learning objective will be to find patterns and relationships in data. An activity will be to collect the resources that are required to manufacture the 10 bookshelves in 1 hour. There are a number of materials to facilitate this activity, including Lumberjack Tycoon's exploration, harvesting, and inventory mechanics. And then there are a number of assessment opportunities for this activity as well. We can access the namespace IDs and the stack number to see what the students have collected, and to check up on the timestamp to see if the students are on track with their resource collection. But we can also combine the timestamp and location data to see where the students have been, to see if they have picked up patterns in a Minecraft world. So for example, the data will show us that students are spending more time in the forest or jungle biomes because they realize that these biomes yield the most wood, and therefore spending time to harvest trees from there would maximize their bookshelf production. So we can introduce more activities into this plan later on by repeating the creating and validating the craft plan steps. But in each repetition, we can introduce new challenges, such as creating items with more complex recipes in higher quantities or in a shorter amount of time. So to recap on the framework as a whole, we first enter the decomposition phase, which guides us through the breakdown of a learning standard and an existing commercial game into components. These components then inform the connection phase to help us design learning facilitating gameplay activities, or LFGA for short. And these tell us how learning behaviors exhibited in the learning standards are being quantified by the game stats associated with the gameplay that reflects said learning behaviors. And in that connection phase, we also design a companion tool to help us more fully address the learning standard. We then take these LFGAs into the activity design phase to help us design a game-based learning activity plan that the instructors can integrate into their curriculum. This framework was used by a grant-funded project to identify a number of gameplay that could facilitate learning related to the computer science standard 2DA08. And this also helped us design the Minecraft Factory Planner to help us more fully address 2DA08. For future research, the team will conduct a pilot study to integrate the previously mentioned activity plan, Lumberjack Tycoon, and Minecraft Factory Planner into the instructors' curriculums to solicit feedback on the usability and feasibility of the activity plan, as well as students' engagement to the gameplay and the learning. And while this research has presented an example approach to the framework, teams can incorporate any methodology for other games and standards that best suit their needs to build new digital game-based learning environments for today's youth. This concludes my presentation. Thank you very much.
Awesome. I'll ask one question and I'll let you ask them. So at the beginning of your presentation, you talk about how, I think it was when you're showing Mario and you're talking about how it maps to two different types of learning theories. You said constructivist and what was the second one?
Constructionism and situated cognition.
Right. So I wanted if you could give me more information on how constructivism or situated cognition, what those theories are and how they map to this.
So I think the emphasis on situated cognition and constructionism is that learning is built through the interaction with the concrete environments that the students are in. So I think games emulate this a lot by presenting, tutorials or levels that's specifically designed to help facilitate the training and the learning of specific skills to help students succeed in those levels. So I think this is where that overlap between game design and the learning theories apply.
What's the difference between the two then constructivism and situated cognition? What's the difference in those learning theories? Why are they different? Like you put them both up there. Do you understand any differences between them?
That is a good question, and I might get back to you on that. My understanding is that there is quite a bit of overlap, but I think there might be more specificities in the different theories.
Okay.
You used a couple of terms that I wasn't familiar with, like the core gameplay loop, secondary and tertiary. Do those have specific meanings? Because you almost were using them like they were, and they're not just abstract.
Yes. So the core gameplay loop. So these gameplay loops refer to actions that the players engage with regularly, throughout the game. So the core gameplay loop, secondary and tertiary loop, they're basically actions that the students repeat on different timescales. So for example, in Mario, the core gameplay loop will be kind of granular second-to-second action, like move left, move right, or jump. A secondary gameplay loop would be goals or more higher complex actions that encapsulate or contextualize the core gameplay loop, such as complete this level or defeat 10 Goombas. And then the tertiary loop applies to a much larger, almost game-wide scale. So it could be beat the game, save Princess Peach from Bowser's castle.
Cool, thanks. Another question, sort of a loose one, but it almost seems like the combination of Mindplex and your learning standard was an uncannily good fit. Did you consider other learning standards, and are there any that would cause exceptional difficulties in using this process?
So that's a good question. I think we picked this game partially because we also have a deep connection with the Mindplex team. But I think just kind of going through the Minecraft's abilities, going through the wiki, looking at kind of their mechanics and their systems, I think it just really facilitates a lot of the learning behaviors very well. But I think that being said, I think there can be other games that can be part of the consideration. But I think we selected Minecraft or Lumberjack Tycoon because of the connection that we have, and just kind of a lot of it's a good opportunity to facilitate a lot of the learning behaviors that we have in mind already.
Let me ask this question in another way. Can I pick any game and map it to a learning standard?
No. So this framework, the decomposition process will mostly help you with this. As you break down the learning standard and the video game into the components, you see what the game has to offer to facilitate this learning standard. You may realize that as you're trying to identify mapping, it might be really difficult, and it might also be really difficult to design companion tools to facilitate that. And this is probably the part where you have to consider another game. This framework doesn't help you establish mapping between any learning standard and any game. It's just to help you identify a game that could help you best facilitate this learning standard.
Can you give an example of a different game with a different learning activity or something, just to contrast to this idea of data focused and Minecraft, because Professor Butler said there was a nice match between them.
Mm-hmm.
Is there any other games that maybe you've looked at or you've discussed in the past, or different examples you can give of something else?
There's an example that I can think of, but I can't really explain in depth. But I think one example I think is Dr. Clark's famous example of using Assassin's Creed to cover some subjects in history, because there are some Assassin's Creed games that has like historically accurate environments, and I think these can be good environments to help facilitate learning regarding history in that time and space.
Okay. All right. Hopefully people can hear me back there. I don't know. Is there any questions from anybody else in the audience? Let me just make sure that everyone hear us? Probably should have tested that before we started the presentation. I don't know. I don't know if the volume's. Yep, no questions. Okay, good.
Just say no questions.
Okay. Awesome. Okay. Well, I think that's all we got. You did.
Did you want to?
Oh, yeah. Any questions here? Yeah.
Okay.
All right.
All right.
No questions. All right. Well, thank you very much. I will be closing this room down, and if you're wanting to stay for the next one, just jump into the next Zoom, and I'll start it up here in just a second. All right. Thank you.